In this video, we're going to review information from lesson 83 through 91. So it could be a little bit long. We'll take one screen for every lesson. So we're starting with lesson 83, multiplying whole numbers and fractions together. That would be a problem like 3 times 1/3. And a good way to show this is if you have, we'll start with pictures like 1/3, 3 times. There's obviously a way easier way to do this, but just kind of remembering how this works. This would be like taking 1/3 3 times, so just add them together. So we have a third here, and a third here, and a third here. And that would be 3/3, or 1. Now the quick way to do this, I'll set it up over here, I think we have space to do it. This is the way you should be thinking of it at this point. Just make a fraction out of 3, make it 3/1. And this would be equal to 3 times 1 in the numerator part, and 1 times 3 in the denominator part, so we get 3/3, and that equals 1. Then we'll take in another slide, we'll talk about cross-cancellation, which makes this even easier. If our problem was 4 times 3/4, here's what we do. We got to make it 4/1. And then this would be the same as 4 times 3, we'll use a dot for multiplication, over 1 times 4. And whenever we have a common factor in numerator compared to denominator, we can divide by that common factor. So we can divide this 4 by 4 and divide this 4 by 4. And we would end up with 4 divided by 4 is 1 here, and 4 divided by 4 is 1 here. So the new problem is 1 times 3 over 1 times 1. I'll write that out. I wouldn't expect you to do that, just so you can kind of keep track of what's happening here. And that would be 3. Now coming back to the original problem and making this way shorter, 4 times 3/4. Draw the fraction bar and put a 1 here. Then you notice that you have a 4 in this position and a 4 in this position. So it's really easy just to say, I'm going to divide that 4 by 1, sorry about that, and this 4 by 1, and then I get 3/1, which is 3. So that's the way, this method, not this one, but that was just sort of an extensive showing you why it works kind of thing. Lesson 84, the topic is multiplying fractions and whole numbers, which sounds a whole lot like lesson 83, it's just switching the order. So in this kind of a thing, we're saying, what is 1/3 times 15? And here you're asking, what is 1/3 of 15? So with logical reasoning, you might think, well, if I divide 15 into 3 equal parts, one of those parts is equal to 5. So you could think of it that way. 1/3 of 15 is equal to 5. But if we follow through on draw a fraction bar, look at the numbers in the numerator sections here, the 1 and the 15, compared to 3 and 1, and it should jump out at you. What can you divide into something down here that also goes into something up here? And it's the 3. 3 goes into 3 one time, 3 goes into 15 5 times, and then we end up with 1 times 5 over 1 times 1, or 5. If it had been 2/3 of 15, very similarly, we'd make it 15/1. We do the same thing. 3 goes into 3 one time, 3 goes into 15 5 times, and that would be 10/1. So this is how it works. Lesson 83, lesson 84, let's move on to lesson 85. Now we've really laid a good groundwork for multiplying fractions, which is the topic of lesson 85. So an example of multiplying fractions together would be like 1/6 times 6/7. And when we do this problem, we can see, we could make it 1 times 6 over 6 times 7. And that would be 6/42. Then you can divide both numerator and denominator by 6 to reduce this to 1/7. However, much quicker and more beneficial for you in the long run to examine the numerators and denominators before you start multiplying. You notice there's a 6 in each one of them. So this is really obvious when you see the same number appearing in the numerator and the denominator, and it's not always that obvious. It might be something, I'll show you in another screen why it might not be so obvious, but this would be simply just do 6 goes into 6 one time here and up here, then 1 times 1 is 1, and 1 times 7 is 7. Now let's take a look at something like this, but a bit more obscure perhaps, we might say. if we have 6/15 times 4/9, there's a couple of different options. You might notice that there are a couple of common factors. First of all, 6/15 is not in lowest terms. So you could divide 3 into 6 and 3 into 15. Or you might notice that 3 goes into 6 and 3 goes into 9. And you can take your choice here. It doesn't matter which one you reduce. You'll end up at the same place. So let me take the route that maybe is not as obvious. And I'll divide 3 into 9. And it goes 3 times. And 3 into 6 goes 2 times. Now I'm comparing 2 and 4, which are even numbers, to 15 and 3, which just happen to be odd numbers. It just proves that 2 won't work as a common factor. The only factors of 2 and 4 are 1, 2, and 4. And 2 and 4 don't go into 15, and they don't go into 3. So that's it. I mean, this is going. When I multiply this out, it's guaranteed to be lowest terms because I've already done all the reducing I can do. 2 times 4 is 8, and 3 times 15 is 45, and sure enough, that's lowest terms, and this problem is done. Lesson 86 is on multiplying fractions and mixed numbers, and in this lesson, you're going to encounter mixed numbers times mixed numbers, and mixed numbers times fractions. 2 1/4 is the mixed number in this example. Of course, 6 is a whole number. This is called a mixed number because it has a whole number and a fraction part. 2 is the whole number, 1/4 is a fraction. There are several approaches to doing this. I'll teach you the most common method, and that would be to convert the mixed number to an improper fraction. So if you may remember the sequence for this, I'll do 4 times 2 plus 1, all over 4. 4 is going to be the denominator. So 4 goes in the denominator, and 2 times 4 is 8, plus 1 makes 9. And I'll rewrite 6 as 6 over 1. Now I could do 9 times 6 is 54, and 4 times 1 is 4. I'm not going to do that yet, though, because I'm hoping that you're really conditioned at this point to say, can I reduce this before I multiply it? Make the numbers smaller to work with. So when you compare 9 and 6 to 4 and 1, what do you see that you can divide into both of them? Or to something in the numerator, something in the denominators. And I hope you're seeing that 4 is an even number, 6 is an even number, therefore 2 will go into both of them. 2 goes into 4 twice, 2 goes into 6 3 times. Now this is going to be lowest terms when I multiply it out. 9 times 3 is 27, 2 times 1 is 2. This is, how many 2's in 27? It would be 13, remainder 1. I combined a couple steps here, and that would make it 1/2. So 27 over 2 equals 13 and a half. Lesson 87 is on models of division with fractions, and I don't want to spend a lot of time with this because by now you should be experts at working just with the numbers. But it is a nice way to remember and use some logical reasoning when you finish doing a division problem with fractions to ask if your answer is reasonable. If you think of division of whole numbers, if we had 8 divided by 2, which could also be written this way, you learned that you can do this with repeated subtraction. How many times can you subtract 2 from 8? And when you go down to there's nothing, the remainder 0. Oops, erase that. Shouldn't put a subtraction symbol there. And then minus 2 gives us 0. So you see 1, 2, 3, 4 subtraction symbols. So that's a 4. So if I have a similar problem where I have 5/8, which is what the shaded part of this rectangle is, divided by 1/8, which means how many 8s can I take away from this model? Well, there would be, let me change colors here. There would be 1 here, another 8th here, then another 8th, and another 8th, and another 8th. So I could actually get 5 1/8s out of 5/8. So that's kind of how you can use a model of division to help you remember kind of how to make sense of division with fractions. And then if I had the problem 1/3 divided by 2/3, you can't subtract 2/3 from 1/3, at least not a whole time. So that would help you reason out why this answer will be a fraction. And we'll take a look at that in the next slide. What is the answer to 1/3 divided by 2/3? Okay, I promised we would look at 1/3 divided by 2/3, but I want to go to another topic first, and we'll come back to that to finish up this slide. This is actually a multiplication problem that I have here, 1/2 of 6. And I wrote that because I want you to see how when you do this problem, you could actually, most of you know 1/2 of 6 is 3. It's the same as 6 divided by 2. And that points out the relationship between multiplication and division. That if I want to do 6 divided by 2, I can work the other way. I could actually make the 2, I can't say it's equal to, but I could think of the reciprocal of 2, which is 1/2. Then I could think of the inverse operation of division, or the opposite operation of division, which is multiplication. So kind of working from 6 divided by 2, I could say, if I keep the 6 and change division to multiplication, I can just take the inverse of 2 and I'll get the same answer. So just to make an algebra statement, if I have a whole number over a whole number and I want to find the inverse, I just flip it. So inverses are helpful because they can help you change any division problem to a multiplication problem. So with this problem, I can write it as multiplication. If I say 1/3, I keep the first term, I keep this, then I change this and change this. So I'm going to follow the keep, change rule. So keep this, change division, multiplication, and change 2/3 to the reciprocal or inverse of 2/3. This is going to become times, and then I have to flip the 2/3. The definition of reciprocals, by the way, or inverses, there are two numbers whose product is 1. So I can prove that the inverse of 2/3 is 3/2 when I show that when I multiply them together, I get 1. And I can divide both sides by 3, divide the 3 into the numerator and denominator, and can divide this denominator by 2 and this denominator by 2, and end up with 1 times 1 over 1 times 1. So sure enough, the reciprocal of 2/3, which is this originally 2/3, is 3/2. In other words, now the answer to this division problem will be the same as the answer to this multiplication problem. And if you're using logical reasoning, you might think it through to say that, how many times can I subtract 2/3 from 1/3? And I hope you're thinking it's half a time. I can only do it 1/2 of a time. So when I go ahead and do my reducing before I multiply, over here I'd say 3 goes into 3 one time, and here 3 goes into 3 one time. And the answer, of course, is 1/2. So 1/3 divided by 2/3 is 1/2. And let's just look at a couple more examples of division in the next screen. But we're always going to be changing division to multiplication. Well, let me backtrack on that. I'm going to show you an example where you actually wouldn't have to change it first. Okay, this is going to be a rather unique division problem. I'm going to create it as we go here. I've got 4 ninths, so I'm going to divide it by something. And then for my numerator, I want to pick something that will go evenly into 4. So a nice choice is 2. And for the denominator, I want to pick something that goes evenly into 9, which would be 3. Now this is very rare that you get a statement where you can actually do 4 divided by 2 and 9 divided by 3. But this actually does work. 4 divided by 2 is 2, 9 divided by 3 is 3. So the answer to this problem that I started with is 2/3. And let's go through what considered to be the normal division algorithm or way of doing division, which is do the keep, change. So I'm going to keep 4 ninths. I'm going to change division to multiplication. And I'm going to change 2/3 to its inverse, which is 3/2. Then I can reduce before I multiply. 3 goes into 3 one time, and into 9 3 times, and 2 goes into 2 once, and into 4 twice. And here we go. We get 2/3. Same thing. This is so rare that you get, this only works if you can get remainder 0 when you do 4 divided by 2 and 9 divided by 3. But occasionally you'll see a problem where that kind of works, and it's cool to do it that way. So that covers division of whole numbers by fractions. Actually, I didn't really stick with whole numbers. I better go one more screen, because I kind of taught the next lesson here. But I will go ahead and do, I actually just taught lesson 89, but let me go back to lesson 88, and we kind of combine these two. So one more screen here. Okay, if we have the whole number 7 divided by 4/5, I'm just going to make it a fraction. And now it's just like the last lesson. So we'll make it, remember to keep that, change division. So it's 7/1, division to multiplication, and change 4/5 to 5/4. And we can't do any reducing before we multiply on this one, so 7 times 5 is 35. 1 times 4 is 4. Then we have to think, how many times does 4 go into 35? The answer here is going to be a mixed number. 4 times 8 is 32. Remainder 3. So it's 8 3/4. And I don't really have room to write that down there. So I'm going to circle that answer, which is what you should do when you're doing a lot of work and it's kind of hard for you to find your answers. Put a circle around the answer of that problem. So that we actually covered 2 lessons, lesson 87 and 88, dividing fraction by fraction and dividing whole numbers by fractions. Lesson 90 throws mixed numbers in here, and you really have all the basic stuff you need here because you know how to multiply mixed numbers and you know how to divide fractions. So we're just going to convert these mixed numbers to fractions, improper fractions. Before we do the first problem, 4.5 divided by 2 1/5, it's convenient to think about how am I going to know if my answer makes sense. And you can see that this is about the same as 4 divided by 2, so your answer should be somewhere close to 2, just so you know you're in the ballpark. So it's good to estimate an answer, round off and estimate before you do your division, or after if you want to, just to make sure that your answer is reasonable. So I'm going to convert this before I change it to multiplication, because I don't want to get too confusing here and do too much at one time. I'm going to convert each of these mixed numbers to fractions. So when I'm doing 4.5 as I'm changing that mixed number to a fraction, I'm going to do 2 times 4 is 8, plus 1 is 9. And I'm going to do 5 times 2 is 10, and 1 more makes 11. And now I'm going to do the keep, change. Keep 9/2, change division to multiplication, and take the inverse of 11/5, which is 5/11. Wow, I got a lot of prime numbers here. 5 is prime, 2 is prime, 11 is prime. 9 is not prime. But the factors of 9 are 1 and 3 and 9, and that doesn't go into either 2 or 11. So I know this is going to be lowest terms when I do my multiplying. Now, lowest terms doesn't guarantee it's not going to be a mixed number. And it is going to be a mixed number. It's going to be 45/22. But it does guarantee that once I do my division here to find out what this mixed number is, this mixed number will be in lowest terms. And sure enough, 1/22 is lowest terms. So this would be 2 and 1/22. Oops, 22. So that's an example from lesson 90, and just a kind of a quick review. And then we got one more to go through. This is order of operations with fractions. Next slide will be order of operations. The order of operations with fractions is the same as it is with whole numbers. You do anything in parentheses first, then you multiply and divide any multiplication division you have, and then any addition and subtraction that you have. And we have this convenient little memory device, please my dear Aunt Sally. That stands for parentheses, multiplication, division, addition, and subtraction. The tricky thing is, if division comes first, then these two switch. And if subtraction comes before an addition, you do the subtraction first. So when you get to these things, that multiplication, division, this addition, subtraction, you do them. They're kind of interchangeable, whichever one comes first. So if I had a problem, if it was just whole numbers, if I had 6 divided by 2 times 4, I have to do the 6 divided by 2 first, which this would be simplified to be 3 times 4, or 12. If I didn't do that, if I followed the rule for multiplication first, I would get 6 divided by 8, which is 3/4. It's obviously a way different answer than 12. That can be a little bit confusing, but just remember that there's not a priority here for multiplication division. See, they're on the same line, which means whichever one comes first. And often you'll see the words multiplication and division left to right. And that means you start at the left side and you work just like you read, left to right. If you get to a division first, you do it first. When you've got down to it's just addition, subtraction, you do subtraction first if it comes first. And just so you have a heads up that it won't be too long until you put another one in here. Maybe say 1a powers. Well, of course, you're not going to have that with fractions. And then it becomes, pretty please, my dear Aunt Sally. Let's look at one example. This is actually problem number 3 on page 195. And here we have a parentheses, and we have multiplication. We have a couple of divisions. The one that you might overlook is that this is a division right here. And actually, this division bar functions just like parentheses. It groups everything above the bar into one group and everything below the bar into another group. So we're going to do everything above the bar, then do everything below the bar, and we'll be down to one number in the numerator and one number in the denominator. So when we do in the top number, we're going to get 6 plus 4 is 10. 10 times 2. Then at the bottom it would be 18 divided by the sum of 2 and 4. We only do 2 plus 4 first, and you probably realize it's because it's in parentheses, and parentheses has priority over everything else. 2 plus 4 would be 6. So now we still have this grouping symbol that we have to account for. This bar, this fraction bar, division bar, you could call it either one, means that we have to do 10 times 2 and get that answer, and do 18 times 6 and get that answer. So we're going to go ahead, I have to kind of move down here to this space, and 10 times 2 would be 20. 18 plus 6 is 24. And you could say you're done, but you also don't have lowest terms. We can divide by 2, or we could divide by 4, and you always want to pick the largest number so you can get done in one step. It's always nice to do that. So I'm going to divide 20 by 4, divide 24 by 4, and this is just the equal fractions property, which says you can divide the numerator and denominator of any given fraction by the same number, and you'll get an equal fraction. So we would get 5 6. Just remember, 4 over 4, this is what I divide it by, is equal to 1. And when you divide any number by 1, you get the same number. It just looks different. So that's a quick review of order of operations with fractions, and that wraps up our review video.